In this video, we're going to discuss compound events. What are compound events? Well, basically, we can use existing events to make new events, as described by this Venn diagram on the right. Event E represents students who like English, and event H represents students who like history. What is the intersection of E and H? Well, the intersection of E and H is the number of students who like both English and history, which is represented by this, by the pink area in the Venn diagram. A union of E and H are students who like either English or history, or maybe English and history together. So that's represented by joint area of event E and event H. So everything that you see shaded in front of you, either red, pink, or blue, that represents the union of E and H. So here's here the Venn diagrams that represent the or and situation with events A and B. So the union of event A and B is actually we use this notation, this symbol, kind of like a U shape, which represents the union, and the union means put those areas together. Now, intersection or and means the area where the two events overlap, and it's denoted by this upside down U shape. That's the intersection of event A and B. Rules for example. A and B are two events, and we know that probability of event A is 0.7122, and the probability of event B is 0.1487. We also know that the probability of A and B, meaning the intersection, is 0.0862. Find the probability of A or B. Okay, so we know that this intersection area, the probability is 0.0862, and then the entire event A the probability of event A is, probability of event A is 0.7122, and then we're gonna shade event B in orange, and the probability of event B is 0.1487. So if we just add the probability of event A and the probability of event B, we're going to add this shaded area twice, right? Probability of A or B. We're going to add the probability 0.7122 plus 0.1487. So if we put it in the calculator, let's see what we're going to get. we get 0.8609, but like I mentioned, that includes the part where they overlap twice. So what we need to do is we need to subtract the area, which corresponds to 0.0862. So minus 0.0862 will give me the probability of 0.7747. All right. You probably notice that I use the probability and the area interchangeably. And in the future, that's what we're going to do. The area represents a probability. So the previous example actually led us to this formal addition rule. If we know the probability of A, probability of B, and the probability of intersection, then the probability of A or B will be probability of A plus the probability of B minus the probability of the intersection. All right, so that's our formal addition rule. Let's apply it. So here we have, what is the question? What is the probability of getting a red card or an ace of hearts when selecting a single card from a deck? We're gonna let event A represent getting a red card and event B represent an ace. Then let's say probability of getting a red card or an ace. Probability of A plus probability of B minus probability of A and B. So probability of getting a red card. Well, half of all of the cards are red, right? So that probability will be 1 out of 2, half. Probability of B is getting an ace. So what's the probability of getting an ace? Well, there's 4 aces out of 52, which simplifies to 1 out of 13. Okay, and minus where they overlap. Well, overlap meaning the card is red and it's an ace. How many cards like that do we know? Well, there's 2, right? 2 out of 52. All right. So we're gonna have, I think our common denominator when we simplify will be 26. So 1 out of 2 plus 1 out of 13 minus 1 out of 26. So 26 is a common denominator. So we're going to have 13 out of 26 plus 2 out of 26 minus 1 out of 26. So the end result is 14 out of 26, which will simplify to 7 out of 13. So that's our answer right there. I think here, this is a typo in the setup. This is what is the probability of getting a red card or an ace of hearts? And then we just, in event B, it's just getting an ace. There's nothing about getting an ace of hearts. So I think the problem meant to read getting a red card or an ace. If we actually figure out the probability of getting an ace of hearts, we're going to get a different number. Probability of getting a red card is 1/2, and an ace of hearts is one of these cards. So we're going to add an ace of heart, which is 1 out of 52, and we're going to subtract it out because it's intersection of a red and an ace of heart, and we're still going to get 1/2. All right, so I think it was actually a typo right here. Okay, guys, so I'll see you in the next video. We're gonna talk about using relative frequency distributions to make probability statements.